Now we'll look at the ideal gas law. The ideal gas law is represented by the formula PV equals nRT. So let's look at what all of these variables stand for. A few of them should be very obvious. P stands for pressure, V stands for volume in liters, N stands for moles, and we've worked with that before, and T stands for temperature. Remember, the temperature needs to be in Kelvin when we're working with these gas laws. The only new variable is this capital R, and that is a gas constant. You will always be given the gas constants, and you can see them down here at the bottom. Note that there are 3 gas constants. So what is the difference between these? If you look closely, you will see a different unit used for the pressure in each one. So 0.0821 atmospheres, 8.31 uses kPa, and 62.4 uses mmHg. So we would need to look at the unit given for pressure in a problem before determining which of these R values we need to use. Please note that the ideal gas law works best at high temperatures and low pressures. That is when gases behave in the most ideal manner and with the fewest number of moles possible. So obviously, the more gas molecules you have, the less likely they are to act as an ideal gas. Now, unlike in some of the previous videos and with the previous laws, we will be doing a little bit of math for the ideal gas law. Luckily, these are pretty simple because we just have to locate the information we have been given, label it correctly, plug everything into our equation, and solve. So let's check out the first problem. A 5.60 liter sample of an ideal gas contains 0.954 moles at 742 millimeters of mercury. Calculate the temperature. All right, so we were given 5.60 liters, and liters indicates volume. We were told 0.954 moles. It tells us what that is. That's moles, so it represents N. And 742 mmHg is pressure. So we need to use this formula and then solve for temperature. Let's plug in what we know. We know pressure and volume equals the number of moles multiplied by R. Oh, we don't know R though. We have 3 options, so which one should we choose? Well, we see up here that our unit for pressure was mmHg, so we should select the R value that also has mmHg. And finally, we need to find T, so we're just going to leave T. Let's go ahead and simplify. So we have 742 multiplied by 5.60, and then that is equal to this 0.954 times 62.4 times T. So we've narrowed it, we've simplified it down to this, and now we solve for T. So the temperature of this gas would be 69.8 Kelvin. All right, now you try. Pause the video and give this a try. Don't forget, your temperature must be in Kelvin in order to proceed. Good luck. Okay, let's see how you did. So we were told 1.22 moles, that's N, 27 Celsius, but we need Kelvin, and 1.59 atmospheres, which is pressure. So the Kelvin temperature is 300, just add 273. We're going to use the same formula, so let's start plugging in. We have pressure. We don't know volume this time. We're looking for volume. Equals the number of moles multiplied by R. So which R value did you choose? Well, we were given ATM as our unit for pressure, so we should locate the R value that also has ATM and plug it in. And finally, we were given temperature. We converted to Kelvin, so we used the 300. Let's simplify. So we have 1.59 multiplied by V equals, and then multiply all these 3 numbers together, and then solve for V. 18.9 liters. So I hope you got that answer correct. Thank y'all for watching. That's the ideal gas law.